Hello. So today we're looking at the vector and parametric equations of a line in 2 dimensions or in R2. So what does this mean? So I've written out the equations for the vector equation and parametric equation of a line in 2 dimensions. So the vector equation of a line has this format right here. So vector R0, vector M all live in R2. M is called the direction vector, and R0, it represents some point on the line. Our parametric equation of a line is very similar. We're just taking out the coordinates from our vector equation. So we have the x coordinate of our line, our y coordinate. Here the m1 and m2 make up a vector in R2, and that is the direction vector. Y0 and x0 and y0 is like a point on the line that makes up our R0. So these two forms of the equation of a line are actually interchangeable quite nicely. So let's have a look at what questions were asked. So find the direction vector and a point on each line below. Okay, not too difficult. All right, so in part A, we're given so what form of the vector is it, of the line is this? This is actually the vector form of the line. And our direction vector is this one right here. So A, our direction vector, we'll call it M, is 6, -1. Usually the direction vector, you can recognize it because it has the parameters, in this case t, multiplied by it. And the point on the line, usually we denote this by R0, is the other vector. So in this case, 2, -1. So it does not have a parameter multiplied by it. So B. So what is our direction vector? So our direction vector, we're going to take, so in this case, we have the parametric equation of a line. So we're going to look at the coordinates or the coefficients of the parameters for each coordinate. So the x, for the x coordinate, our coefficient of our parameter is 2. That's the x coordinate of our direction vector. For the y coordinate on our line, for any point on our line, the coefficient of the parameter is -1. That's the y coordinate of our direction vector. Now for a point on the line, again, we're going to look at each coordinate of a point on the line, and we're going to look at the constant term. So in this case, in the x coordinate, the constant term is -1. For the y coordinate, the constant term is 4. So a point on our line, one point on our line is -1, 4. Now for C, well, this is interesting. So this is a vector form of the equation of a line, and we have it written like this, just as a simple vector, -6, 3t. Why don't we rearrange that? So we have it in this form, in this kind of form. So vector r equals -6, 3t. Let's break it up. So we're going to write as -6, 0, plus 0, 3t. Let's scroll down, give ourselves some space, or -6, 0, plus t times 0, 3. So now that we have it in this form, we can read everything off quite nicely. This is our direction vector, and this is our point on the line. So our point is -6, 0, and our direction vector is 0, 3. So last one, D. So again, this one is pretty straightforward, very clear. We'll just put it right here. D, our direction vector is 2, -5. 2, -5. And our point lying on the line is -8, 3. Good. All right, next question. How many do we have? We have just the 2. That's good. So a line passes through points A and B. Sketch the line. Okay. Determine the vector and parametric equations of the line. All right. Okay, let's plot these 2 points. I think that's the best way to sketch a line, plot points. So let's draw some axes in here. Okay. I think that's enough space. Let's label y-axis, x-axis. All right, and we have our origin middle. So we got 2, 4. I think that's enough. All right, so point A, let's use a different color for each point. 1, 2. Let's say. Point B, let's pick another color. Let's use green, so -3, -2. So this is our B. So now let's draw the line between these 2 points. There's our line. All right, looks good. So now part B, so that's our part A. All right, so now part B, determine the vector and parametric equations of the line. Vector and parametric, all right. We need to find the direction of this vector. Now, how do we do that? Well, that's actually not too difficult. Let's a little smaller. Let's scroll over so we have a bit of space. All right, so we need to find the direction vector. So we can do that by actually finding the vector AB. So why don't we find the direction AB, right? That vector is the direction of our line. So how do we do that? B minus A. So let's plug in our points. B is -3, -2, minus A is 1, 2. Our direction vector is -3 minus 1, -4. -2 minus 2, -4. That's our direction vector. Okay, so a point on our line can be either A or B. Let's choose A. It's pretty simple. It's like our coordinate vector for A, 0A. And now we just need to take this information and put it into the format of either the vector equation or the parametric equation format. So let's scroll over and let's do that. All right, so let's start with the vector equation. R, vector R equals R0 plus T M. What is R0? It's 1, 2 plus T, or M is -4, -4, and T is just any real number. How about parametric form? In this case, we just take the coordinates of our vector form. So x equals 1 minus 4t, y equals 2 minus 4t, and our t is any real number. Good. So our first step was to find the direction vector, m. Our second step was to find a point on the line, and we took that information, then we just plugged it into the vector equation and parametric equation forms of a line. Good, so that brings us to the end of our session today. If you have any questions, feel free to send us a note at info@raisethemarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching.